Hello and welcome everyone. So I'll be explaining this problem, Codeforces round 742 div 2, problem B.MEXor mix up. Basically, you're going to be given two integers, a and b. A will be always positive, b could be greater than or equal to 0. So the difference between a and b is that b can be greater than or equal to 0 and a is always greater than 0. What you have to do is like Bob, let's assume that you're Bob and you're Bob wrote down an array of non-negative integers with MEX value of all the elements equal to A and XOR value of equal to B. So what you have to do is what Bob, the array that Bob wrote down, you have to make that array's length as minimum as possible, fulfilling the condition that you're given. What is the condition? The condition is that first of all, you have to find the shortest possible length of the array that Bob wrote. If it's possible, although they have said that it's always possible, which is obvious. I will show you why. And yeah, so you have to output like the shortest possible length of the array that Bob wrote, and fulfilling the condition. What is the condition? The condition is that the MEX of all the possible members, MEX of the array, MEX of the total array has to be equal to A, and the XOR value of all the elements has to be equal to B. So this is the condition that we have to fulfill. Now, what is MEX? They have also described what is MEX. I hope you know what is MEX here according to the definition here. Again, I'm telling you that MEX is like a minimum excluded member of the array, which is not included in the array, but the minimum value, minimum non-negative integer, that is not included in the array. That's all. That's what MEX is. Yeah, basically, and let's talk about the constraints here. T is quite big, 5 into 10 to the power 4, and A and B are also those two numbers, but they are quite small, 3 times 10 to the power 5, and B is 3 times 10 to the up to 3 times 10 to the power 5. So that's when I thought that maybe I had to do some pre-computations, because there's no other way apart from that, because T is quite big. You cannot just go out for a brute force solution. So we have to like think about it, like storing some values, as the constraints of A and B are quite small, 3 times 10 to the power 5, like, right? So yeah, that's exactly it. Now, before jumping on to the solution, I have to tell you one thing, is that before jumping on to the solution, we need to know a certain operation of XOR. Now, if you have learned about it before, you would know that XOR has a particular operations which is going to help us in order to solve this problem, which is like, let's say A XOR B equal to C. If this is the case, then B XOR C is also equal to A, and also A XOR C is also equal to B. Now, why is that? How to prove it? As A XOR A XOR A equal to 0. A XOR A equal to 0. From this point of view, we could just somehow prove it that if A XOR B equal to C, then think about it. If I XOR A on both sides, what happens? A XOR A, this part gets cut out. What remains is B XOR 0, which is B. Basically, B is equal to A XOR C. So that's how we could prove it. Okay, this is a common operation that you should know for XOR operation. So this is going to help us in order to solve this problem. I'll show you how. But now, yeah. Now let's demonstrate the. Let me demonstrate the full solution now. As we know the operation of XOR, what actually we're gonna have to do is, okay, first let's think about the MEX part. Now we need to make an array such that the MEX of all the elements is equal to A. Now, what is at least amount of value that we can put in our, what is the least amount of values that we are bound to put in our array. Think about it. If our given value is a, let's say a equal to 5. Now, what are the values that we must put, we are bound to put in our array? The values are 0, 1, 2, 3, 4. Exactly. From 0 up to a minus 1. These values must, or these values are bound to have, bound to take place inside the array that Bob is going to create, or the array that we are minimizing the members. But these values should be able to contribute here to this array. I hope you're getting why, because think about it. If the element of the arrays is this, like what could be the MEX apart from that? The MEX would be the non-negative integer, the smallest non-negative integer that is not existing in this array, which is nothing but what? 5, right? So 5 is not there. So up till 5, apart from 5, apart from a, from 0 till a minus 1 should be, and they are bound to contribute inside our final array that we're gonna minimize the length. So they will definitely always contribute. So that's the initial part for the MEX. Now the thing is, what was the next part? The next part was the XOR value. Now we know they have told us that we have to XOR all the values of the array. So as a similar fashion, we will XOR at least amount of values that we have got. Think about it. We will always XOR. If we're given A and B, we know that A is for the MEX part. So what we're going to do is somehow we're going to pre-compute from 0 up till a minus 1 the XOR value of this thing, of these values, because there will always be at least these values will always contribute in my array. So we will initially create the XOR 2 of these values. Now how do we do that? We're gonna just outside the test case, we're gonna just pre-compute the XOR up to 3 times 10 to the power 5. Now how is this gonna help us? Now when we're gonna take A and B, we know that we have XOR values up till a minus 1, from 0 up till a minus 1. Now think about it. If this XOR value itself, let's say the XOR value is T, if this XOR value itself is equal to B, initially, after just putting these values, the values that are bound to be part of this array, and making the XOR operations, if they're initially equal to B, then we don't need to add any more values. The answer would definitely be A, because we how many members in the array right now? Of course, from 0 till a minus 1, the values are A number of values are here. That's the case when for the least amount of values that we're bound to put, if their XOR value is equal to B, right? Equal to B, then the answer is A, because there are a number of values from 0 till a minus 1. So we're like doing that, we're fulfilling both of the conditions. The MEX is A and the XOR is B. Now what if this value, this XOR value is not equal to B? That's the other case. Okay, that's the other case when this XOR value is not equal to B. Then we have to draw some then the condition that we talked about earlier about XOR operations, that A XOR B equal to C, then A XOR C equal to B, that condition comes and helps us. Why is that? The answer will always lie. Now the bottom line is here that the answer will always lie from A till a plus 2. Answer could be either a plus 1, and a plus 2. Now we need to find out when it's going to be a plus 1 and a plus 2. Okay? When it's going to be a plus 1 and a plus 2. Now if I take you to the code part, this is the first condition that we just talked about. Now apart from that, what exactly do we need? think about it. If the XOR value up from 0 till a minus 1 is not equal to b, then we know that we need b, right? We need the XOR to be equal to b. Now, if I compare this, okay, let's take another fresh page. Now, up till now, we have calculated the t value and the b value. Now, think about it. We need the XOR as b. Let's draw the result. We need this XOR as b, but we have t. How do we get this value? How do we get this value? Exactly. That's the same operation, XOR operation that we're going to do. We are just going to compute t and b. We're just going to compute this t and b. We're just going to XOR these two one. T and b. If we do XOR of t and b, we know that the result will nothing but be this, because we already know this, that if a XOR b equal to c, then a XOR c equal to b. Obvious, right? So yeah, if we want our XOR of all the values to be b, then we just do the XOR operations from t with b, right? That's it. Now you might think that, okay, that's the answer, but no, we also need to take care of another case, which is, what if when you XOR this t, remember what was that t? That t was XOR from 0 till a minus 1, right? 0 till a minus 1. And remember what you did? We did XOR operations of t and b. What if this XOR operation gives value equal to a? Now, if this value gives equal to a, what is actually its does that mean? It means that I have to add this value in my array, but that is not appropriate. That is not what I'm bound to do, because if I add a somehow, if the condition arises that the t XOR b becomes a, but I cannot add a in my array, because that would just not fulfill the condition of the first condition, which was like the MEX won't be a, then the MEX won't be a. So so we need to take care of this extra part. For this case, if that's why we need to give an if condition. We will say that if t XOR b is not equal to a, then we're just gonna output a plus 1. Just the extra one. This if that value is not a, apart from any other value, then we're just gonna simply add it, because of the operations that XOR gives us and provides us. But if that condition becomes equal a, then what we're gonna do, we're gonna simply add another value, extra value. We don't know where it comes from. Just put another extra value in my array and calculate the total XOR. That XOR value is going to give me some value, and then I'm just going to XOR that value with the value that I want, which is b, and that's going to simply calculate the required value that I want. So I hope you get that. Ultimately, that leads us to making extra 2 values apart from a. So ultimately, a plus 2 values we need to add. A total number of elements would be a plus 2. I hope you're getting that, why I'm saying this. So this was the true 2 conditions that we needed to take care of. If I take you to the code part, this is the prefix part, just the prefix XOR part. Before initializing, commencing any of the test cases, we are just gonna do the XOR part here, and this is the test case of I'm gonna take A, I'm gonna take B, and then this is the first case that I talked about. This is the general case. This is the temp is referring to the t that I talked about, and if that t is equal a, then answer would be a plus 2, extra 2 values I have to add, otherwise a plus 1. Because that won't contribute to a, because this value like if this temp I include in my array, that would just violate the rule of the first condition. That's why we need to add extra random array, a random value, and then do the XOR. We're going to do the XOR, and from that XOR we will get to know what the value, what is the extra value that we need to put in order to make B for just for this case. And if that XOR is not equal to A, then we know that answer would be A plus 1. Yeah, I hope you're getting I hope you understood the problem solution. So yeah, till next time, goodbye.